Now we're going to talk about the memory model. Let's go back to our diagram and draw the threads and blocks and kernels. So every thread has access to something called local memory, and this is memory that's private to that thread, things like its local variables. So the thread can read and write from local memory. And the threads in a thread block also have access to something called shared memory. So all the threads in this thread block can read and write to the per block shared memory. It's important to understand that shared memory is shared among the threads in a block. This is a small amount of memory that sits on the SM directly. And finally, there's global memory. Every thread in the entire system at any time can read and write to global memory. So threads in one kernel can read and write from it. Threads in a later kernel can also read and write from it. So every thread, to recap, has access to its own local memory, has access to shared memory that's also accessible to threads specifically in its thread block, and to global memory, which is accessible to all the threads everywhere. Of course, everything we've been talking about is on the GPU, but there's also a CPU. The CPU thread launches the work on the GPU, and of course the CPU has access to its own memory, which in CUDA we call host memory. Usually data is copied to and from this host memory into the GPU's fast global memory before launching a kernel to work on that data. We'll talk later about how CUDA threads can access host memory directly.